Welcome back. Today we're going to be looking at this whole test review. We might not be doing every type of problem and all the way through, but I am going to be giving you hints so that you can work those problems. And then if you have questions on the problems, what we really want you to do is come and join our office hours on Tuesdays and Thursdays from 8 to 12. That way you can ask the questions that you have instead of just copying down some work that I give you or that Dr. Solis gives you and hoping that it helps. I'd rather you identify the questions that you have and really come and ask those questions to us so we can work through it together. Let's look at some helpful hints though. We're looking at solving by factoring, but it's got a coefficient as an A, so it really kind of gets a little tough and dicey, and I want you to remember that whole slide and divide thing where you slide over that way, and then at the end of your factor you're going to divide it out, and make sure that you're really remembering what you're solving for. When you're solving for x, sometimes that sign flips at the end if you don't remember. Sometimes because you've gotten into two factors. I had a student email me like literally today asking about why his signs are different on his homework than on what he thought he should get. And it's because when you get to the end of your factoring, you don't have your solution yet, you just have a factors. Usually when you plug those plug x or solve for x by setting it equal to 0, your signs pretty much flip every time. So that's an important last step. Remember that slide, and then later on you're going to divide. You're going to divide that 2 back out. Okay? If you have questions, office hours. Solve by factoring. We're looking at the same type of thing, except we're moving those terms over first. And then we're looking at this problem. We're saying, what's the factor tree of negative 20? And my guess is it's going to be some iteration of plus or minus 4 and plus or minus 5, and I'll let you solve for that. But if I had to guess, and I'm looking for which one of those two numbers multiplies to give me 20, so they need to multiply to give me negative 20. That's a bad way to write that. These two things need to multiply to equal negative 20, and they need to add to equal negative 1. And that's what we're looking for. That's the kind of the factors that we're looking for. Solving using the quadratic formula, that's that song, that negative b plus or minus the square root of b squared minus 4ac all over 2a. And the important hint here is that you're labeling A, B, and C, including the sign that comes before. So you're taking A is technically 1 here, B is negative 6, including that sign, C is positive 18, including that sign. So there's your hint. You're just going to plug those straight in and do a little algebra. Same thing for the next one. Solve, method of your choice. If you have a choice, I would always just jump to that quadratic formula, practice it all day long, and you know what, even if your homework is telling you solve by factoring, you know what you can do? Check it with the quadratic formula. So you show the work for factoring, and then you're like, I need to make sure I got it right. I'm going to do the quadratic formula to check it, because it'll work every time, every single time the quadratic formula works. We're looking at the same thing, factor. This one's going to be a little tricky factor, right? But if we remember that u sub where we take u, make it x squared, and then we rewrite our equation as x squared. I'll give you a little hint, and I'll give you a hint in colors. X squared plus, well, I'll do that in red, plus 5x squared minus 36. Hopefully these colors might help a little bit, because now what we're looking at is, that u equals x squared is blue. So if I make everything that's blue a u squared plus 5u minus 36 equals 0, now maybe we have the ability to factor that. I think we will. Okay, let's see what else we're looking at. The rational equation factoring, remember we're just looking, you don't like fractions, I don't like fractions. We're looking for that common denominator, that least common multiple or least common denominator. It's going to get rid of all those bottoms for us. Right here it's looking like it might be 12, but I'm not promising you that. Your job is to find it and see what is the least common multiple between all the denominators that's going to get rid of them all and give me an easy, nice solve. Same thing here, but we've got x's in our denominator, so our first thing that we need to think about is this, those red brackets, the same thing as this times this? And if it is, which often it is, that might be your least common multiple right there. But you need to check that before you go ahead and decide for it that that's true. And then you also need to make that note at the beginning of this problem. Note that X better not ever be 6, and X better not ever be 5. Because if it is, we broke our 3rd grade rule that you can't divide by 0, and that's the worst thing we could possibly do. That's one that's really important for you to learn how to do and to come to office hours to learn. I've already posted a video doing one of those. I want to do this one for you, but I really want you to get the practice doing the review and not just copying. So maybe we'll do it at a later time. But that's a really good problem. Like put like 3 stars by it. That is a good problem, and if you can do that problem, then you can trust your algebra skills and you can trust your ability to solve problems, because that's a pretty tough one. All right, we saw a lot of these word problem troubles in our last test and our last review, so I might go ahead and set this up for you so you can kind of see. I always read it. A rectangle, I drew it. We're done. Has an area, wrote it. We're done. Areas, I underline it, say I'm done with that. Of 98 square inches, boom. 98, label those units. A lot of people not labeling units. Square inches. The length of the rectangle, boom. Length, I wrote it. Every time I read something, I write it to make sure I know that I've used it. The length of the rectangle is double, okay. Length equals 2 times. I don't know what it's double, but I know it's 2 times it. The width of the rectangle. Find the dimensions. Okay, well, that's all I need to know right there. So now I'm just going to solve. I'm going to set up some stuff. I'm going to use the formula that I know, the area is length times width. Plug some of those numbers in and see what happens. Probably set 98 equals the length times width. And then probably plug something over there on the left into something on the right. Don't forget about interval notation for all of the following. We're going to remember that if we see the underline, the less than or equal to sign, we use brackets. And if we see the less than sign, we use soft brackets, right? That's the interval notation. That's the little shortcut to that. That's the whole problem right there I just gave to you. Graph the following intervals. Same exact thing. You see those brackets? You go -4. You draw a bunch of lines. You can make it all the way to 7. And you go open circle, close circle, shade it all in, right? Awesome. Okay, I'm going to let you do the linear inequality and ask questions if you have any questions. That one doesn't look like we'll flip the sign. This one doesn't look like we're flipping any signs. Nope, this one we might end up flipping a sign, won't we? If we move, if we're moving things to one side, right? We might move this x over. We might subtract it from both sides, end up with -3x. We might move that 4 over, add it to both sides, greater than 9. And then right here, that's that little thing I wanted to give you a little hint on. We divided by a negative number, right, on both sides, so we better flip that sign. We have to flip the sign because we divided by a negative number. We flip the sign, we're left with 3 over 1, which is just -3. Interval notation looks a little bit like brackets. Nope, it doesn't include. No brackets. Soft bracket, right? Because it does not include it. So if x is less than, it's going from -infinity, goes all the way to -3, and then it just stops. It says no more. I stopped at -3 because I better be less than -3. Cool? All right, inequality, inequality, inequality. Simplify square roots. This is factoring. This is just practice for you to factor. Real important that you just think about what multiplies to what. You could do it all at once if your brain can get that perfect square right away. And if you can't get the perfect square, you can do it slowly. I don't mind either way. Let's see. So like 45. The fast way would be to know that 9 is a perfect square and it's a factor. And then you can pull that 9 straight out, right? So it turns into 3 times square root of 5. The long way, which is totally okay, is to go ahead and do it a couple times and go 45, 3 times 15, break it down. 15 is 3 times 5, break it down, and you see those 3's that get pulled out. Which, so like for instance, on this next one, if I were going to do it the slow way, or not slow, but if I were going to do it a way that I know I can make it happen every time, square root of 125, I'm going to break it down and say, I know it goes into 5. Well, how many times does it go into 5? 25. And then I'm going to break it down again. I'm going to say 5 times 5. Holy moly, there's all these 5s, right? Well, 2 of them make a square, so we can pull it out, and we're left with 1 of them. So those 2 go away, and we're left with just 1 on the inside. So a couple different ways to do that. Don't forget, anytime you see the exact same process, but if you see that negative, it just pulls right out and turns into I. And we're just keep working the problem like normal, but pull that I out. Graphing points on the table, don't forget it's always x comma y. That's the little shortcut or the little thing to remember there. and you plug that number in, you funnel a number through the system. A function is just taking a domain and turning it into a range, taking an input, turning it into an output, taking an x, turning it into a y. So we take that 0, we funnel it through this system of numbers, and it turns into -2, and we plot that point, right? So if I call that B and leave you to do A, B, C, I'll call that B, right? And you can do the rest and graph that line. All right, here's that Hoy-Vux that I mentioned in a video, and I say, okay, well, I see a y equals. I see a y right there, so I don't need VUX for this one. So I know it's going to be a horizontal line, right? I know it's going to be a horizontal line, and I know it's going to be a horizontal line that hits -5. Boom, we're dunsies. Not too bad. X and Y intercepts. Remember, this is plug 0 in for Y. Then plug 0 in for X. And see what happens. See that you don't just get a nice, easy numbers to graph. Slope. Remember, if you watch that video, slope is defined as rise over run, change in y over change in x, and a whole lot of other ones too. These are the two that really help us for this, because we're going to find two nice, easy points. I'm going to zoom in real big right here. I'm going to say, where's two? I see this one looks super nice. And let's find one more nice. Oop, that one looks super nice. So then I'm going to go left to right like I'm reading a book. I'm going to go 1, 2, 3 down, 3 down. That's a negative sign. And then I'll change the blue. 1, 2, 2 to the right. That's a positive sign. And so I'll go, my rise was red and it was a -3, and my run was 2 and it was positive, and that's my slope. So m equals -3/2. All right. Calculate slope through 2 points. Give you a hint. We've got x1, y1. We've got x2, y2. We've got a nice little formula that says y2 minus y1 over x2 minus x1. That's just 2 subtractions and 1 division. You got that. I believe in you. Oh, that's the whole review. So there's some shortcuts for the review. Again, if you have questions on this review, come to office hours and bring the questions because you get stuck. We want to help you, but what I don't want to do is just feed you all of the answers so we think we have it, and then we get to the test and realize I don't have it. That would be worse than really getting it and coming to office hours to work on that. So hopefully this helps a little bit. Hopefully it gets you started. It doesn't give you the answer, but it gets you started working through the answer, and then we can spend the next week really focusing on learning what we know, learning what we don't know, and addressing that. Thanks for watching. We'll see you soon. See you in a little bit.